Hello. Today we're going to be talking about logarithm properties and laws. But first, let's kind of review what we've talked about in our last video. We determined in our last video that if you have logarithms of the same base, this example has a 5 on the bottom, and you look at their inputs, we can put them and condense them into one logarithm by keeping the same base and multiplying those inputs. So that means that log base 5 plus log base 5 of 125 equals log base 5 of 5 times 125, or log base 5 of 625. There you have that. So let's kind of think of this in terms of something a little bit more familiar from past years. So what we want to think about here is if we wanted to write this as 5 to the first power, and we multiply that by 5 to the third power, we know based on exponent rules that that would be equal to 5 to the power of 1 plus 3, or 5 to the power of 4. In this example, I'm multiplying two numbers with the same base. And when I do that, I have to add the powers, add the exponents. And let's write that out in words. When you multiply by the same base, add the powers. Now, logarithms are basically the inverted version of that, or the opposite. When you are adding logarithms, you multiply what's inside. We are really just adding two logarithms and then multiplying this input over here, which is exact opposite of multiplying numbers with the same base and adding the powers together. They're opposites of each other. Let's write that out for logarithms as well. So over here in red, we could write when adding logs, you multiply the inputs. Now let's think about in terms of division. We could have 2 to the 7th power being divided by 2 to the 4th power. Based on your prior knowledge, you might remember that when you divide things with same base, you are turning it into adding the powers. In this case, this would end up being 2 to the 7 minus 4, or 2 to the third power. And let's write the side here. When you divide exponentials, and that's always with the same base, you subtract the powers. This means that we can make our second logarithm rule. If we reverse this statement and say, well, when we're subtracting logarithms, we would then be able to divide those inputs, kind of like what happened in the first rule. So let's write out an example. We could write out, say, something like log base 2 of 32, like so. And then we could subtract log base 2 of 8. And if we think about that in terms of this new rule, this is going to end up equaling log base 2 of 32 over 8. And we can write out in words what happened there. We could say that when you subtract logs, and these are the same bases, you divide their inputs, the part in the parentheses. So now if we go back into this problem, kind of prove to ourselves that that actually is true, well, we know that log base 2, well, 2 to the 5th power would be equal to 32. So that's equal to 5. 2 to the 3rd power equals 8. So now we have a 3 right there. And in theory, this should be equal to. So if we make that a logarithm, we can do. So now this would end up being log base 2 of 32 divided by 8. Well, 32 divided by 8 is equal to 4. And we know that this log base 2 of 4 is going to be equal to 2. 2 squared is equal to 4. So now we basically have written 5 minus 3 equal to 2, which is definitely a correct. And now finally, let's write out our logarithm rule, which is rule number 3. Law number 3 is that if we have log base a of some number p, and we subtract log base a of a different number or the same number q, that ends up equaling to log of the same base a of p divided by q. And that finishes off our second video on the laws of logarithms with logarithm law number 3.